I'm inside of Unreal Engine 5.7, and here's what we're going to be making. I've hit play, I'm running as Manny, there's the call button, I'm running up to it, it's changing the color, the doors are open, there's our extraction button, running up to it, the doors are closing. End level. I've eliminated all the various time delays and we're keeping it very simple. We're going to be using overlapping volumes and a little bit of easy logic with some medium level blueprinting. Let's get started. Welcome to this Unreal Engine 5.7 Simplified Arc Creators Extraction. This is the 2025 Unreal Engine Authorized Instructor class that I'm putting on for free. Anyone who'd like to use this for classrooms, for learning, development, or expanding on it, please feel free to do so. For the setup, all you'll need is Unreal Engine 5.7 and a third-person template. Our simplified Unreal Engine extraction flow is going to go like this. We will walk up to the call button station. We will be within a collision radius, so the button will color change. The door animation will open the doors. We can have a timer here, whether the doors stay open or closed. Inside the elevator, when the doors are down, there's going to be another extraction button station, and there is going to be where we have a timer for the doors to close, the door close animation. Then we're going to fade out and end the level and quit the game. Now, we're not going to have quite as many bells and whistles as the actual Arc Raiders, the in-game extraction flow. When you call the button, there's a 45-second delay with audio alerts. Lights are flashing and spinning around in a 360 fashion. When the elevator arrives, the doors open, the lights change to green. There's quite a few audio noises. The audio is incredible in this game. Then when we have inside the elevator are the two extraction stations. They're open for 2 minutes. Then the elevator automatically leaves, the doors close, or you go in to one of the extraction buttons, return to Speranza, you hit the button, then there's about a 3 to 5 second animation that happens, then the doors close, and you have your end UI, your return menu, and your round recap. So that is the simplified version that we're going to be doing together versus the actual game version. If you're familiar with Arc Raiders already, then please skip ahead. For those of you that are not, please watch this next clip where I go over the elevator extraction in detail, and you can get some inspiration and see just exactly how the real game goes about doing their extraction phase. Have you ever played an extraction shooter? Specifically, the new Arc Raiders. Well, it is quite intense. We're battling against other players. We're battling against an enemy Arc. AI robots in the air, on the ground, all over the place. And the goal is to collect loot, run back to the elevator with your loot, and then call the elevator up and extract from the elevator safely without getting killed by robots and or players. And you can see here, I'm having quite a hard time getting back to Speranza, which is your home base. Hello everyone, my name is Logan Pinney, and I'm going to be explaining a rough simplification of the extraction process made inside of Unreal Engine. I wanted to start that off with some excitement, some action, but here's a short process video. So we start in the lobby, we hit play, we're entering one of the various maps that are available to go and scavenge loot, and we're shot up onto the surface at a random spawn point. So here we are with our gear from our stash, and we're on the surface looking for equipment. And we're going to go and run all the way, and I'm going to skip past and just show you here. We're going to open up a map and look, there are various types of exits and extractions. And so the closest one here is at this point, and I'm going to cut to going in front of it. This is the elevator. There's a call button. It's got a red dot on it. That's the button. And we have a pop-up UI that comes, E to extract, call the elevator. We hit the button, the light turns yellow and starts flashing around. We got a 45-second timer, and we're hiding. We're waiting, want to get shot by either a player or shot by one of the enemy Arc, the robots that you're battling against. So it's a PvP and a PvE. The environment and players are both your enemies. Players can also be your friends, but it's up to them if they're going to be friendly or not. So once the 45 seconds has elapsed, then the elevator doors are going to open. The light turns green, indicating that you can extract. You can get back to your home base. Inside the elevator, there are two computer panels with a little bit of blocking on the sides. You have to interact with the panel, and then you have a few seconds before the doors close. During this interaction period, you can still be shot, as you saw in that earlier clip, and it can be a pretty intense time. Right now, it's the start of a round, nobody's around me, so it's easy for me to record this, and we can go in and call up, we're ready to go home, and they have an animation attached to that, and then we're done. We punch in the right hand down on the lever, and the doors come up, and we return to Speranza. Now that you've seen the simplified version and the actual game, let's go over what we are going to learn and how we are going to apply this to Unreal Engine and replicate the extraction. What you will learn by the end of this class is how to take a third-person template and turn it into a basic extraction mechanic for testing. We're going to block out simple elevator and call stations with buttons and blueprints. We'll learn how to use those blueprints to trigger level sequences. We'll learn how to use those blueprints to trigger material changes. And we will also be playtesting and iterating over simple extraction mechanics. I'll leave opportunities and ideas to elaborate at each phase, and you can take the tutorial and the lessons and apply them to your own ideas or games and adapt them, morph them into how you want them to be. Now that we've gone over our full plan for the lesson, let's get started with Unreal Engine 5.7, and I will meet you there. I'm inside the Epic Games launcher. I already have the latest version of Unreal Engine, which is 5.7. You can use the latest or any of the versions that contain the new third-person template. You'll notice they have a new home button. So I already have a project open, our Arc Extract, and I don't need to go back to the launcher. I can now use the home button to create a new project or open up an existing project or check out some samples. As you can see, Stackobot has been updated, and there are other samples below. The Lyra sample and the new motion broadcast sample, as well as the game animation sample. I recommend you go and browse those at your convenience. All right, we are going to select New Project, Games, Third Person, and this one we're going to do Blueprints, Desktop, Maximum Quality, no variants needed, and we're going to save that in a location that you'd like. I'm going to call mine Arc Extract, and I've already created that. So I'm going to go back to that initial third-person template level. And here we are. And the first thing I'm going to do is roughly model out our call box, because that is the center focal point, core of the logic, interacting with the button and interacting with the button inside the elevator. So I'm going to jump over to modeling mode, and now I'm going to begin to block out a button. I've grabbed a cylinder. I'm going to scale it down to a button size. So you can start with the button or start with the cube. It's really up to you. This phase is about making something that will be functional. It is not about making something pretty. After that button, I'm going to be putting a box here, just a regular old box, and make it a rectangle. This is our call box, essentially. And after that, I'll grab another cylinder, put that underneath as the supporting beam, and then we will begin to have a little bit of a recognizable call box station. If things aren't quite moving the way you want, you might have snapping turned on, and it might be on an increment that you don't want. So head up to that little top menu bar, as you saw me do, and change your snapping to a smaller unit, 5.1, or you can turn it off. But I like to have it on as I'm blocking out. Here, blocking out a single leg for it, and then I'm going to use the pattern tool to make a small 4-grid pattern. I could easily just make individual meshes, but I at least wanted to show you that we can use the pattern tool and then make a hierarchical instance static mesh from that. Inside the pattern tool, we're going to set this to grid and a much smaller distance here. And straighten that out, make that about 10 and 10 and 2 by 2. And now I have just the position I want for those. I'm going to hit accept. And we're going to use this middle top pole as I want that to change color. And maybe in the future, that's what's going to be used to spin a light around, indicating that the elevator is on the way up, or indicating that the elevator is here and ready for extraction. But I know I want to have the button change color as well as an aspect on the top of the call box to change color or do something. So that's why I'm blocking that out. And now we're going to do a little bit of tidying up. I'm going to make some folders in the extract folder. So we have our materials, our mesh, and speaking of, I want to get started on the button material. So I'm going to go right click, new material, new button material, apply that just to the button. Let's open it up and have a go at setting up a active and deactivated button state. Hit 3 on your keyboard, push it twice, and right-click, convert to parameter. We're going to have one of these be our deactivated color, and one of them going to be our activated color. They are parameters, so we can change them in material instances. And one of them is going to be green, one of them is going to be red. Pretty simple. The next thing we're going to do is linear interpolate between those. So hold L on your keyboard, drop a linear interpolate node, right click on the alpha, promote that to a variable. That is going to be our state. So we want to set our state to be 0, meaning we are going to be all red. If our state is converted to 1, we're going to be all green. Next, I'm just going to do a little bit of multiplication in the emissive channel. So we have an emissive strength. We might want to have that animated or changed with some kind of logic. So I think 5 is a good value. I'm going to dial the roughness down to be 0.15. Tidy this little node tree up. A super simple material and really useful for testing. And it's all driven with one variable, our state. So we're going to comment, change this in the blueprint interact. Okay, so that I know that that is why I put that there, because I have a hard time remembering what I do sometimes. So please comment your work, organize it. It's not for me, it's for your future self. Great, now we have the button base set up, not that entire box. No, we just want it on the button. Great, now we have the button. We can do the same logic in a material instance for the top pole when we get to that. So I'm happy with this little block out. Let's hit play, run over, check it out. And I'm walking right through it. That is a problem that we can easily solve. So find those meshes and Control B. I have them here. Open them up each individually. Go to collision. Then add either a simple box or a simple sphere or a 10-point collision, and you're going to get a proper collision on that. It doesn't need to be anything fancy. This is block out. Right, so now I've got the button. And we can do a little sphere here. I can get really crazy and remove that and put something even tighter on, which is entirely unnecessary, but I will show you that anyways, and we'll get one that looks really nice and not that one. And this one here is a perfect match. So let's hit save on that and now do the last cylinder. We'll put on a capsule on that one. It's popping up a little bit on the top, but that doesn't matter. Now let's move our player start over so we don't have to run as much because I'm incredibly lazy. Now hitting play again, and pointing in the call box, great. I can run into it. It has collisions, and I can probably even jump up here and jump on top of it. I just hit F11 to go full screen. That's a little shortcut if you didn't know that already, but I'm assuming that you did know that because if you're here, you're probably not a basic user. Great, let's move on to the next phase. It's great we have this as a mesh, but really we need it as a blueprint. So I made a new folder, blueprint folder, and right-click, new blueprint, actor class. Let's name this BP call button. And open that up. I'm going to try and position this so we can see our screen as well as the blueprint, but I advise that you have multiple monitors while working with Unreal Engine, as it really will help your efficiency on multitasking and having blueprint open on one window, your level open on another window, and then materials or something else open on a third window. I prefer 3 monitors. 2 is great, 3 is amazing. 1 is still manageable. Okay, so here we are. I'm adding static meshes to the blueprint components. Those are the same meshes that we used to build our block out. I'm going to add the box, the button, and it's really only going to get interesting when I begin to add the bottom pattern cylinder. And the reason why, you might ask yourself, that was really silly that he decided to use a pattern to make 4. However, imagine I'm in a massive open world and there's not one call box. There's potentially thousands or tens of thousands, in which case it's something that the player is going to be interacting with a lot. And that's when something like a hierarchical instance static mesh is going to be incredibly beneficial. So after I pop on this button, we're going to go over that workflow. All right, now here is where this trick is going to occur. So we have our pattern inside of our outliner, and it's not transferring over to the blueprint. That's when we need to go over to our modeling mode, and we're going to go over to transform, and we're going to harvest those instances. Now, when we right click or we control C, we're going to copy this from the outliner, go back to the blueprint, select the box, and then hit Control V. And now we have the proper structure, and you're going to see it is not a static mesh. It's actually listed as a hierarchical instance static mesh, which takes a little bit to practice saying. HSIM is much easier to say. So when you see that, that means that it's a hierarchical, and it will change with the HLODs, the hierarchical layers of detail, levels of detail. I'm going to put on a few simple brushed metal materials. They're basically the same as the world gray, but there are some metals. If you didn't know, there's a bunch of template materials that I like to use while I'm blocking out, so we're not just stuck with that world grid. And you can go and use whatever materials you would like for your temporary call box. I'm going to save and compile and put this into the world, replacing the mesh that we had made. Within the blueprint, I have renamed everything and organized it. So we have our SM callbox as the parent, then our HISM pole legs, our SM button, and our SM top pole. Now let's hit add and scroll down to collision. We're going to add a box collision. This is where the player is going to be overlapping. So position that at the base and then modify the box extent so that we have just about 1 or 2 persons' lengths in front of the box. You want it to be fairly close. You don't want it to be a huge radius. The player has to get right up there to the box in order to interact with it. And remember, this is for testing. We would be setting up in the next phase button interaction, but right now the main focus is getting the core logic, the core loop of our extraction. How do we get out of the game? So we need to make sure that we can have our game loop completed before we start refining things like making sure we have really cool button interactions and amazing looking meshes. Testing first, function over fashion is my motto when I'm developing and designing. Once your box is good to go, hit compile and save. Now head over to the event graph. The next thing we're going to do is set up a little bit of early temporary logic. Over on the right-hand side, under your box collision, scroll down and on component begin overlap. We're going to drag off of that pin and do a print string, the easiest thing we can possibly do. And we're going to say that this print string trigger call box. If I can get the spelling right, I have fat fingers, so I don't often spell correctly. Apologies for that one. All right, print string, pretty straightforward. It's just going to be debugging. I'm leaving the duration to be 7 seconds, but how do I know that it's my player, the character that someone's controlling is going to overlap? Well, I'm going to do a quick branch check here. I'm going to hold down B and create a branch and have another actor. Which actor? I can't just put an actor into the condition, so I'm going to add a tag to our actor. So I know that I'm going to do that. I'm going to add a node here called actor has tag. And what is that actor? Well, it's the player. So pretty straightforward. I'm going to use the tag player. Therefore, it's not going to be triggered by an AI or something else. So if it is a player, now I have a boolean return value, pipe that into my condition. If it's true, then we're going to print the string. Now running in front of it, nothing's happening. I'm the player. What's going on? Well, I didn't actually establish that the player has the tag player. So I'm going to exit the game and find the BP third person character, which is in the project by default. Once you've navigated to the blueprint, open it up. and we're going to go over to the class default, type in tag at the very bottom. We're going to add the plus sign and add the tag. Type in player. This is where it is critical that you do not make a typo. I've spent hours going crazy before because I've had a dyslexic moment and had 2 letters flipped around. Hitting play and testing it out. Walking in front of it, and you can see, yep, there we go. The top left-hand corner, we have the trigger call box, and it's from the player. So everything is working for our overlapping collision for the player to interact with the call box. We have our collision overlap. Now let's hit play and run around a moment. So it does nothing, and our elevator really isn't an elevator yet. So what I'm going to do now is begin to transform the template into a mock extraction elevator. I'm going to select all those meshes on top and these sides, so I missed one there, and raise them up. So I don't want it to be too high, but I want it to be high enough where the player can get on top and have some kind of gameplay where they're battling other players or other AI bots like in our graders. Or I also want to make sure that they have enough room, headroom, to go underneath. And okay, yeah, that's way too much headroom, so it doesn't need to be quite that high. Now lowering it down and hitting play again. And this is where I highly encourage iteration. Play, iterate. Playtest, iterate. It's a 1-2 combo. Okay, you're going back and forth all the time. So you want to see, can they still jump up on there? How's that height? I'm starting to feel better about that height. I think I enjoy that height. So I'm going to remove the green parts. Those are actually going to be what is going to be animated to go up and down for our doors. And they're going to be going and making all kinds of cool noises like they do in the game. But for now, I am going to just have them right there and just see if there's any other shapes that I want to use. I'll probably end up merging those shapes together. And I'm going to go and browse to where this platform shape is, the ramp, and get a cube and take that cube and position it underneath. I do have snapping turned on and making it easy, and I wouldn't drag out an individual cube like that. You don't need to. With the World Grid material, when you stretch it out, scale it out in any direction, it makes those grids for you, so making it easy to look at. Now I selected that mesh that I'd grouped together, and I hit H, which hid it. I didn't delete it, I just hid it. So if you're wondering where that went, that's where that went. And now I'm happy. Great, we have a base bottom of that. Let's drag it off onto the other side. Group those two together so our pivot's in the middle. Rotate them by holding Alt, making a copy. And now I have all 4 of those together. Let's merge those together. And I'm going to merge probably all these top parts up here together as well. And change the scale of them and how much thickness do I want. It's push and pull, so I think between 1.5, and put that at the top and see what that looks like, and hit play. And I think that might be too tall, but too high up. And now I'm just nitpicking because that is off by 1 cube and it's bothering me, but I'm not going to let it fix it right now, but I will get back to that. So here I'm hitting Control H and moving that over, so that's unhiding. So if you can hide things and then unhide them, that helps you with your level design. If you didn't know that tip, then now you do. And I'm making this group actor and just moving it up and down and seeing, how do I want to animate it? There was a bit of Z fighting if you saw that weird look on the floor and you didn't know that. Now you know that is what Z fighting looks like. It's on the ceiling above. So I don't like that. I'm going to make this smaller and raise it up, but I have to first select all of them. I should have grouped them. I didn't. So I'm going to make them smaller and thinner and raise them up. And now that ceiling thing won't be a problem, but I'm going to have to deal with that. I'll put it on the floor. We'll put 1 on top and 1 below. And so I think I'm liking that as our basic setup here. And this is beginning to look closer to the extraction elevator. And now I'm coming back to fix that one cube that was bothering me. So making sure everything is lining up properly. You don't have to do this. This is something that only a nitpicking OCD person would try and do because these are all going to be replaced with proper meshes. So once you've adjusted your meshes and nitpicked yourself, then please don't waste your time doing this stuff. It is silly, and I left it in here in this edit just to show you that this is the kind of thing that will really eat your time up, and it is irrelevant. But if you enjoy things snapping together and looking appropriate, then you're probably going to be doing the same thing that I did there. All right, Now let's go into the merge tool. If you didn't know about it, it existed before the modeling mode, and I'm going to select merge actors. There's a few different types: simplify, batch, and approximate. These are great for making echelons as well, which is an entirely another class. But so I'm going to go and save this merged inside of our mesh folder, and that is our, now I've merged, that is going to be our animated door piece. So removing the mesh in there and then bringing in the one that I made and positioning it exactly where I want. I'm going to go into our top view by clicking the 4 dots in the corner, then clicking the dot on top view. And I can easily position this exactly how I like. Another quick tip: if you hold down the middle mouse button, you get a measuring tool, a ruler. So I'm just doing a quick measurement, OCD measurement, making sure, hey, these are about 325 units from the center each, and then adjusting it, tinkering it unneedlessly. So, but just wanted to show you that you could use the ruler tool and to pop into other views if you want to get precision alignment. I'm going to make that taller so that it's covering everything, but not too tall so that there's Z fighting, so a little bit smaller. And now I'm happy with that. Another trick is inside the modeling mode, we can go down here and bake transformations. So I've raised the scale, but then I bake the transform, setting everything back to 111. Now heading over to the create button, cinematics, and grabbing a level sequence actor. I'm going to drag that in front of our call button because that is going to be the sequence that we're going to create to open the elevator doors, call the elevator. And I'm going to parent that to our blueprint. And I'm going to go inside and make a new level sequence and make a new folder called sequences. And this is going to be called ls level sequence underscore elevator open. Once you've made your level sequence, open it up from the open level sequence button. We're going to get our doors, elevator doors, and drag them from our outliner into our sequence outliner. I'm going to put a keyframe at frame 0, and then I'm going to move ahead in the timeline about 45 frames, and I'm going to lower the Z to something like minus 250 or minus 300. I want them to be just slightly above the ground level, and playing with some values, I'm happy with minus 280 for this test here. Now at the top of the sequencer, I'm going to grab the red bar, drag it over because I only need my timeline to be this distance here, this short distance. Switching it to looping playback, I've animated the door going down. Changing my frame rate to 24 FPS, just to show you that if you want to do the cinematic style, you're going to use 24 FPS, and you can change it up there. And I can extend my keyframe, drag it out so that it is going to be longer. And I'm going to hit the curve button here. This is going to open up the animation curves, where we can adjust the and refine the speed and rate of change on the elevator. So now it's taking longer to open up at the start, and then it's hurrying its way down near the end of the timeline. You can experiment with different curve looks. You can change the tangents from auto to user to broken. And you are going to have to select the weighted tangent button if you want to have them broken and weighted. As you can see right now, it's adjusting both sides. And when I flip it over to the weighted, I'll be able to adjust it better. And I always go through this phase where I'm like, how do you get that? Is it broken? Is it user? And it's user, and then we need to select the weighted because I'm trying to drag it out. Nothing's happening. Why not? Well, because we actually have to select the weighted tangent button right there. Toggle weighted tangents. Now, there we go. Now we can start refining that pace even more. Close that and see how that's playing out. And I'm liking that. So we're going to continue on with this as our level sequence that is going to open up from the elevator. Great. Now, how do we get the blueprint to communicate with the level sequence so that when the player interacts, right now when they overlap the volume, that it plays the level sequence? Let's go back into our blueprint, and we're going to add a variable. This variable is going to itself be a level sequence. So let's name it level seq. We're going to select the drop-down menu, type in level, and go to level sequence object reference, and poke the eye. We want this to be a public variable because I might have many call boxes and I might have many sequences, and I want to point a specific sequence to a specific call box. I'm going to break the connection to our print string. I'm going to hit C and make a debug comment. Change the color to a red or burgundy kind of color and leave it there. That way I know, hey, that's the thing I was using for testing. It might seem kind of silly with one print string, but I can tell you when blueprints start getting heavy or cluttered, you're going to want to know where you're debugging and what you might need to go back and debug in the future. The comments are just for yourself. Remember that. They are here to help you. Next, I'm going to go up to the event begin play, drag off there and type in create. I'm looking for the create level sequence player. And once I've found that, I'm going to remove the other nodes. I don't need them. I'm going to delete them. And so inside here, I'm going to get the level sequence variable that we had just created and pipe that into the level sequence. So from here, we have created a level sequence player. And I'm going to go off of the return value, drag off there, and promote it to a variable. This variable is our level sequence player. Seq player is what I'm going to call it. And now when we are overlapping, I'm going to get a reference to the sequence player. Once we are overlapped, and that is true, I'm going to play the sequence. Dragging off true, plugging that into play. And now we have our simple logic that will play our level sequence. Now, I know it's not going to play it properly, so I'm pulling off of the sequence and looking for a node keep state. They have a restore state, and I think we need to change this. Well, I don't think I know. We need to change this inside of the sequencer itself, but I just want to show you what happens when you don't do that, because it's something that is a very common pitfall that you're going to run into. All right, so I select the blueprint and we have an error in the bottom. Well, that's because I need to actually pick a level sequence for our blueprint. So inside there, we're going to use the level sequence that we just made and put that reference in there. And now when I walk in front, the elevator doors open. It works like magic. Hold on. The magic stopped pretty quick. The doors went right back up. Why is that? Well, I'm going to select the level sequence. I'm going to go in the details. It's not on autoplay. It's not playing at a specific time. It's not pausing at the end. That's something different. But what we want it to do is we want it to keep its state. So there is a setting. There's a setting inside a sequencer that allows us to keep the state. And I'm going to go back into sequencer and show you that. And it's one of those things where it's kind of buried around. So sometimes you might think it's in one menu and it's actually in another menu. And I thought it was that button, and guess what? It was not. It's trial and error. And I want to show you that, yes, you're going to make mistakes. So I'm going to go back, open level sequence, right click on it. Where was that right click? I know it's in here. You actually have to right click on the animation track up in properties, and then we're going to set our when finished, not project default, keep state. Then I know when I hit play now and walk in front of it, it is going to keep the state. I'm going to close sequencer. That's another gotcha. You want to keep sequencer closed when you're testing that sequence. Elevator doors down, and yes, they are staying down. Perfect. So we have that initial phase set up. Now you're going to say, hold on, I thought there was a timer in our creators and we don't have a timer in here. And you're absolutely right. And we can re-trigger it when I run outside and overlap the volume again. Nobody wants to sit here for 45 seconds while you're testing. It is incredibly easy to implement a 45-second delay within sequencer or within blueprints using a delay node. It's probably best within sequencer once you have everything dialed in. And that might not be the case in every situation. But the point is, we're not going to sit here for 45 seconds. I want it to trigger immediately so we can test it immediately. And I'm going to open up the level sequence, and then we're going to say, okay, well, the doors, it automatically, in the game, it automatically goes back down after 2 minutes. And that's a feature because sometimes when you get knocked down by another raider or a robot, you can crawl. and you have a certain amount of your health bar diminishing over time as you're crawling, you can crawl into the elevator and still interact with the button while you're crawling, and you might get out in time. It could be a hairy experience. So it's really cool. That's where the delay of the timer comes in. And here I'm just thinking, okay, well, I'm going to copy and paste the keyframes. I'm going to have my doors are going to go up after X amount of time. And what is X amount of time? Well, I'm going to put my playhead there, and I can right click at the top and I can add a mark. And I'm going to add a mark there, and then I'm going to move my playhead to the other keyframe, and that's B. This is our time that the doors are down. And I'm going to right click above there in the timeline area and add another mark. And so now I know when I open this up, oh, that's the window that I'm having the doors are down. And when I open up the curve editor, that's even more apparent. We're having our animation, our motion, then a flat line is there's no acceleration or deceleration on any velocity, therefore it isn't moving. So that's the period of time when there's nothing happening, and then it's finished, and then the doors are going to go back up. So that is one implementation. We are going to modify this because we want to have the doors go up when we want them to, using the button inside the elevator. But this logic is perfectly fine, and we can have an override of this logic with our interior elevator sequencer as well if you want. In sequencer, and things get moved around, so don't be too concerned with yourself if you forget where they put the changing the frame rate into time. So we can go over and change our 24 FPS into seconds. That way it's still 24 FPS, but we're being displayed in seconds if you want to see exactly how long your A to B time interval is in seconds, because not everybody enjoys reading everything in frame rates. So I'm moving that down, and I'm moving the B down as well. So now I still have that, and I can check, all right, that's at 10.5 seconds, and that's at 3 seconds. So I know I have a 7.5 second window where it's open here. So let's test that again and see if that waits for the appropriate amount of time. I think we can wait for 7.5 seconds. That's not too long of a time. And I'm just going to stand on the edge and see what happens when it closes. Oh, I'm moving up. Yeah, great. So even collisions work on that as well, which is exactly what I want to have happen in the game. Opening level sequencer back up, and I'm going to go in the bottom right hand corner sequencer, type in 21, change that to 21 seconds. Let's give ourselves a bigger window to work in. I'm going to select the animation at the top and drag the entire thing. That way, this is going to essentially mimic what happens in the game. When we have a small delay while we're calling the elevator. It's not going to be a long one, but it's a little bit of a delay, so we can simulate that there will be a period of time where they're waiting, and I'm going to have that where the top pole is going to change color eventually. So that's why I want to implement that little bit of a delay at the beginning, and now I can change the end of the sequencer as well and move out those closing keyframes for bringing the elevator doors up. However, this is temporary. I'm moving A back over here, the A mark and the B mark to the window, so I know how long the gap is, and I'm leaving the gap longer this time for a little bit of extended testing here just to see if that works. I'm going to save and close sequencer before I test it out to avoid any bugs with that. Yep, there was a bit of delay. Elevator doors come down, and I'm going to stand inside, and I think I changed that to something about 10 or 12 seconds. It wasn't a huge amount of time, certainly not 2 minutes where we're waiting, and then it goes back up, and there we go. Doors are up, and we're trapped inside here, and it's very dark, so we should probably add some lights quicker than later inside of here. I can hold down Control and hit L, and you will add a point light. Believe me or not, it took me probably 4 years inside of Unreal Engine before I learned that. And I was just kind of shocked that It was you're always learning new things, no matter if you've been in here 1 year, 2 years, 5 years, 10 years. So always be humble. I'm always happy to learn new things anytime as well. I don't want a point light though. I want to use a rec light because or an area light, whether you want to call it a rectangle or an area light, they do the same thing. So I'm going to delete the point light, and this is going to be pointing down because we're in some kind of an elevator. So elevators usually have the gross overhead lighting. So we're going to try and mimic that mock style lighting with the overhead light. And I'll also get some of the lights animated in sequencer in no time here. Let's open back our blueprint and begin to work on the material changing, the button change. We did some of the work, most of the work, inside of the material with the state. So I'm going to go off of event begin play, get a sequence node. This is just to help keep me organized. I'm going to move the rest of these nodes down lower. And the first thing I'm doing when we begin play is I'm creating that level sequence player and then making it a variable. And the second thing I'm going to do is I'm going to create a dynamic material instance. And this is going to be for our button. So I had a selection there, SM button. Do you want a material for that? Yes, I do. And now I'm going to check over with that, making sure that, yes, it's element index 0. And which source material are we going to use? So selecting the button, going over onto the material, and I'm realizing, hey, it's not a material instance. So we're going to browse to that, right click, create a material instance. We're going to name it MI button underscore 01. And this is going to be piped into our blueprint here. I'm going to pull off of the return pin and promote that to a variable. And we are going to call this our button color, because we are going to be changing this button color. And I'm probably going to end up poking the eye on this material instance and making it a variable in the future. But for right now, we're going to leave it as is. Then I'm going to drag off and get a button color reference. From button color, I want to set the scalar variable value. We created a scalar that we named state, and we initially set it up as 0. Well, when we overlap, we're going to change that value to 1. We just need to make sure that the parameter names match. So we called it state, so we're typing in state here. And now let's compile, save, and test this out. See if it's going to make our material instance and then change the color of the material instance. We already set up the active and deactivated colors. Boom. It's going green. So that's exactly what we wanted to happen. Is very simple, and we have our material color changing from red to green when we are overlapping and activating using our button color dynamic material instance. And I'm going to drag off and make some space and put a delay node in there. And that delay node is going to be the same time as our sequencer that we're waiting, which I think is 1 or 2 seconds. But let's double check by opening up sequencer and going into our timeline and seeing how long it actually is. And I'm going to move my playhead over top, and it looks like 1 second. So we'll go back and inside of our blueprint, change our delay to be 1 second, compile, save, minimize that, and close down sequencer, then test again. And there it worked. We had our delay of 1 second. The material went from red to green. And that is going to probably simulate, if you have an animation when the player is going to approach and hit E, interact, and then cause the button to change, and you want a time waiting there. And now the doors have come up after the allotted time, and it's still light inside there because we have our area light. Excellent. Now let's work on the interior. So I'm going to remove that old static mesh, and I'm going to bring another copy of the blueprint in, hide the elevator doors. I'm going to put just 1. I know there's 2 computer stations inside of the actual Arc Raiders game, but we're just going to get 1 working for now, and then we can always add a second one. We can change the gameplay later. And I'm going to go back to modeling mode because I do want to at least differentiate this one from the exterior one by adding some very basic blockers. So there's no one firing, there's no AI bots yet. That's something that I definitely plan on creating. But for now, let's just have this one differentiated, and we know that it's going to have some blockers, making sure that there is a little bit of safety for the player. So I'm alt drag off of that and then rotate that so that they're both at a 30-degree and 60-degree angles beside the call box. Blockers complete, and there's another way to merge. I showed you the merge actor tool, but if you go back into modeling mode, there is actually a merge button within it. So we can go to transform and select merge and then type in the SM_blockers, and now we've created our blockers in our user folder, and I'm going to drag that into our mesh folder under our extract. I experimented with adding the blocker onto the blueprint, and then I was moving the call elevator button around, just getting in some different iteration testing. So I thought, can we put the button there? Are we going to put the button up top? Or maybe I'm going to move it over here, and they have a specific amount of time to run to the elevator. That would be a tight time frame before it closed, and just testing if that works. We've got our button inside there, and that button works, but it doesn't do anything. We don't have a level sequence set up, and we need to make a new one. So let's get our elevator close sequence made. I'm going to grab the elevator open sequence and make a copy of it, and this is going to be our elevator close sequence. So the close sequence is going to be attached to the interior call box blueprint, and what we're going to do is I'm going to reverse the keyframes, right? So we're going to move the keyframes backwards, and that way there's going to be still a time delay after you hit the button, and then the doors are going to close. And I already went ahead and removed some of the old keyframes in the first level sequence so that all it did was open up, and now we have one that all it does is close. Testing it out. Yes, it's closing, but we got to get rid of those interiors and make it nice and empty inside. So let's do that next. And now I'm moving on to making the elevator doors a little bit better, not these wide chunks. I want the interior to be completely empty. We have those triangles popping up. I don't want that. So I'm going to make this very large and go into modeling mode and go into the boolean tool and then boolean these so that that's not what I want. I want the opposite of that, where the exterior like that. Perfect, but not big enough. So I'm going to hit cancel and make that shape even taller, much taller. Just make sure we're going all the way through top to bottom, then selecting that and going back to A to B. And now, there we go. That's what I would like, except I'm getting annoyed by those little light cracks. So I'm going to fix those as well. And I'm just going to cheat by taking the ramps, moving them over and making them a little bit bigger so that they're a little bit longer where there's any light leaking happening. And that way I'm just sealing us in here appropriately. It's a nuanced thing, and it was for me just because I wanted to make sure we're getting the right light here. There's the blocker thing. I animated the door first, then did a model correction on it, was to show you this. We've now broken our reference. We don't have the door any longer. What we do have is a new object called boolean. I'm going to move that into our meshes, and I'm going to delete the old door, and then I'm going to right click and clean up redirectors so that I can rename this the same name and not cause any problems. And now that is the new name, but it's still a problem in our world outliner. So I am going to have to right click and reassign that to the boolean, and it's shifted its position. So what we're going to have to do is go to the keyframes and make sure that they are at the right spot. So we'll delete any of them we're not using. We're only going up and down in the Z, and let's make sure it's in the centered on that. And it is. And we go all the way at the top here, which looks like it is now 130 units up, and then we're going to go down to minus 130 or minus 145 units. I think that's at 140, minus 140, and keyframe that. So we'll have to fix both sequences, but that's why I wanted to have a simple two sequences, one of them to cue the elevator opening and one of them to cue the elevator closing. Always go back to the KISS principle. Keep it simple, stupid. I tell myself that all the time. So let's check. That one opens, and the inside No, we got to fix that one. I did not fix it yet. Okay, so let's go and make sure that it is corrected as well. And we have to fix the reference. It's the boolean. And of course, all the location is messed up. So we'll go and correct that and then come back and test again, making sure everything is working correctly. And doors open successfully. And lights changing and doors are closing successfully. It looks like we have an additional keyframe on the closer. I can see because there's a little snap at the end of the, and I go to curve editor, we can really see it. There you go. There's an additional keyframe there. So get rid of that one, save and close this out. And there we go. That looks like a normal motion and not something weirdly snapping at the end. Now I'm going to adjust the keyframes in here as I want it to have a little bit of a different feeling than the opening. I want it to slowly close and then rapidly close at the end so that there's really a sense of urgency as it's going up, that you might be close and then too late. It's already up. So it's subtle, but it's something that I wanted to put in there. Going back to our opening elevator sequence, I am going to put in a light. And we're going to have the light change color. This is the rec light that's inside of the elevator. So by default, it is white. I want it to go from yellow to green when the elevator doors open, or it's going to go from a low emission to a high emission. So the light is low intensity to a high intensity rather. So the light is turning on. But before that, I'm going to duplicate those blockers and drag them up and begin modifying them, because I'm going to make some kind of like a fake, overhead ceiling light where we have the two pieces of metal that are pointed at an angle, so you can blast those LED beams as far as possible with as little light as possible in the office. So there you go. Let's get this dialed in, changing some of these settings like the barn door angle, the barn door length, and the intensity, as I mentioned. On the light, on the area light itself, now I'm changing this within the context of sequencer. And there is something else that you should be aware of. When you're changing within the context of sequencer, when you're outside of sequencer, you're going to flip back to whatever context that you had originally created in. So you'll see that when we're out of the sequencer, the light is not yellow and at that specific intensity. So then I'm going to need to change it to make sure that it starts at the default settings I want that are the same as the initialized settings inside sequencer. So now we can see there its intensity is being animated, and we're turning on the light as the elevator door opens up. Next, we'll go inside and do something similar. We want to change the light from that orange into the green. And this is what I was getting at. I've grabbed that same rec light and dragged it into sequencer in our second level sequence, and it was white. It didn't maintain any of the changes that we made inside of the sequencer in the opening of the elevator doors. So here I'm going to get the same yellow, and then I'm going to animate it to green. And we're going to go in here and I'm going to add something new called an event. And in the event, we're going to double click on that keyframe, and I'm going to grab off of that sequence event and type in quit game. And that's it. And we're going to get the player controller. That's the specific player. That's who's quitting. I'm not even sure that's necessary. I think you can just have the quit game node and we can test both. And we'll test with the controller and then test without it. And I think that if you wanted a specific player to exit, then you use that. But when you have just quick game, it exits everything. Okay, so it's opening up, the light's turning yellow, and then boom, you saw that? The sequence was done, and it reverted back. So it turned green, that worked. But when we had that intermediary period and I select it, look, the settings are not what we want them to be. So I'm going to go in and change the light to be the yellow color, but boom, it flipped back, and it wasn't the color that time. That time it was the intensity flipping back. So initially the intensity is at 8 by default, and I had it set at default inside of ours, I think, at either 0 or 16. Either way, it wasn't the same as what it ended, and we didn't use our keep state trick inside the animation, which we should have done. Now let's test it again, opening it up. The light turns on and stays that intensity, and now it's going green and a little bit yellow. So we have to change that one again, right? So the intensities aren't matching up, and going back in here and making sure that everything, there we go. Let's select the animation in the light and make sure we leave it to be keep state. And we're going to go in and remove the specific player. I think it's not needed. And then I'm actually going to find out that that wasn't the problem. The problem was I had my keyframe. We're supposed to quit right here, and we're not. And the reason is my keyframe was just outside by 1 frame of the timeline. Everything worked in here, and you can see once I debug it with the F9 on our blueprint and then run it in here, and we'll see, do we actually trigger it? I open up and look, and we're going to keep state. I'm going to fix that one while we're here. Just trying to get everything dialed in, wrapped up, and fixing all those little common bugs. Do we quit? There we go. We do quit. So we do hit that node in the end. And let's test it with F9 off. So we're out of debug mode there. And boom, there we've quit. So it was that one single keyframe. Next, I'm going to go into the elevator close sequence, and I'm going to add another event. I'm going to, this time, it's going to be a fade event. And so I'm going to go about 3 seconds back and hit fade at 0, and then move all the way to the almost end of the timeline, and then the fade at 1. So we'll be going fully black, and that's going to fade out like we're returning to Speranza. And now our event, just when that's happening, I'm going to rename the top event here. That's going to be our end game event. And then below that, this is going to be our disable input event. Dragging off that, typing in disable input, we're going to get a disable input node. And that's what you'd think you need. But hold on. Look at that. That says target is LS elevator. It's not the right one. It's level sequence elevator. So it won't actually let us put our player controller or player character in there. And speaking of, grab your player controller node and then drag off and type in disable input. And then you're going to get the correct disable input. And you do need both your player character and your player controller if you want to disable, and we have it available in player character. Get player character, there's disable input as well. So make sure you're using the right one. And now we do need to grab our controller, get player controller, and pipe that in as well. So we're getting the controller and player and disabling the input, then fading out and quitting the game. Save, close sequencer, and let's test it all out. Now we're fading out and we've quit. So that is working. It's triggering in the sequence director the disabled input as well as the quitting game. And one final thing I want to do is the changing of the light at the top of the pole. Now I thought I might go into modeling mode and do a set selection essentially and end up just changing a part of the model and picking specific polygons I want to change the material color, but I scrapped that idea and ended up just making the pole smaller and having the entire pole top be the light. I'm going to browse to the button and make another material instance since we already have all the variables set up. So I brought in that little new cylinder, and I remove the one that I brought in to build it, and let's go in and apply a new material instance from the button. So this will be our MI button 02, and I still have to rename our groups because we have global, scalar, and global vector parameters. So we're going to have this start as a gray, similar to what it is, and it's going to change to be a yellow. So our active is a yellow and our deactivated mode is a gray. So now let's apply that and make sure that everything is looking cool when we play test. Probably too much emission there. So we'll change that, dial that back, move the emission down. Instead of a 1, we'll try a 0 instead of 5. So no emission there. And then we can actually go in and modify the blueprint so that when we trigger, the emission changes inside of the blueprint. And in order to do that, I'm going to need one more of these dynamic material instances. This is for the top pole. So following the same procedure we already did, I'm going to create a dynamic material instance. This is going to be our MI button 2 as the source. Our target is the top pole. Then I'm also going to have to make a new variable for that. And that is top pole is not won't plug in as a target. We need to go back and actually make a material instance variable, not the mesh variable. So if you're wondering why it's not working, oh, right, that would be why. So pull off the return variable for your dynamic material, and we'll rename this to pole color or top pole color. And then we will take a reference to that and bring it down and do the same thing where we are going to set our scalar parameter value, and the state is going from 0 to 1, the same thing. And this time I'm getting another 1, and it's going to be not our state but emissive power, and the value is going starting at 0, and then it's going to be 10 when we're on the yellow orange color. So let's play test this. Boop. And the light is going to that color. Perfect. That's exactly what I wanted to happen. Boop, and the light turns on that color there, and you go, wait a minute, I don't want it. I want it green on this one. And that's why we have to do one more change inside the blueprint, where we make that material a changeable per blueprint. Because right now it's hard-coded, and that's not actually what we want. We want to make it that we can poke that eye and change that material instance to anyone that we want. So we'll promote it to a variable, our source material, and that's going to be our source, our button top pole material for this one. And then we're also going to have a button material. But I'm just going to make the top pole material the exposed variable. So now when I go over to the first blueprint, make another copy of it, and this another copy of the material instance. And I'm just going in here and updating our grouping names. So now we have parameter grouping names, attributes, and button color. So button color and deactive is gray. Active, this one we want to be green. Saving that, and going down, and I'm making sure that's applied inside of our top pole material, and it is. Now let's play test. That one works, going the yellow. Boom, it's going green. So this is, and we're fading out and quitting. So everything is coming together. Well, we covered a lot. So we did our ArcRader's simplified extraction. We took a third-person template and we made a simple extraction mechanic for testing. We blocked out the elevator, the call stations with interactive buttons using dynamic material changes, and we linked those up with some blueprint triggers that triggered level sequences, material changes, lighting changes, and throughout the entire time, we playtested and iterated over these simple mechanics. Now you can see how this simple loop could be expanded on, and I want to see how you take this and expand on it on your own take. So please let me know in the comments what you made. Did you make the same thing? Did you make something even more simple or something better? Or did they have to do a chore or a task? The player needed to collect an item or do some kind of an additional thing before the doors would open. I hope that this taught you a little bit about how to make some gameplay and mechanics, and thinking about when you take a game that you like and play and breaking down one of their concepts, making it your own, and seeing if you can replicate it. I look forward to seeing you in the community. Bye now.